Friday, I noticed that everybody that I asked did not have the mole toll put. I mean, I'm not saying that no one does. I'm just saying everybody that I asked did not have the mole toll put on your periodic table. So I just want to do a quick review of that. Okay, a quick review of the mole toll. So the mole toll is centered around the mole, and you have mass down here, which is in grams, and up here you have molecules, and then down here you have volume. And the volume is in liters, and it's for gases only. At STP, which of course you know what STP is because we've been over it and it will be on the test. So 22.4 liters per mole, that is the conversion between volume and moles. And then between moles and mass is molar mass, which is in grams per mole. So that's how you would convert between mass and mole. And then between molecules and moles, you would use Avogadro's number, 6.02 times 10 to the 23rd particles per mole. And then once you get to the number of molecules, you then have the ability to get to atoms by saying like one molecule has so many of each atoms, or by saying if I have so many moles, that gives me so many moles of those atoms, and we're going to talk more about, we're going to do a couple sample problems of that today. So you might want to put this on your periodic table. It gives you a little guide. Miss Fox has a foldable that she uses for her class. Most teachers have some method of having this map or this guide for their students. So my first problem today is going to be a moles to molecules in a compound. Now, this is not new. All right, I'm choosing my problems that I'm showing you in an example carefully as we're following like a progression here. All right, so this is moles to molecules in a compound. So my example is going to be 4.63 moles of sodium sulfate is equal to how many molecules of sodium sulfate? So to do this, I think like most of you already know, have figured this out, right? This isn't any real challenging problem, right? We're just going to go from moles to molecules using Avogadro's number. So I'm going to start with my 4.63 moles of sodium sulfate. And what you're going to notice is that I really am being careful to always put my compound with my unit. And the reason is because in the middle of the calculations, we're going to start changing compounds, and it's going to be super helpful to you to designate what compound we are working with, because you're going to go from like moles of sodium sulfate to moles of sodium. And you want to make sure that you're keeping track of it, all right? So for every 1 mole of sodium sulfate, you have 6.02 times 10 to the 23rd molecules of sodium sulfate. And now I can cancel these out because they are exact moles of sodium sulfate. And when I run my calculation of 4.63 times 6.02 times 10 to the 23rd, I get 2.97 times 10 to the 24th molecules of sodium sulfate. My 3 sig figs match my 3 sig figs here. So that wasn't real challenging because we've had problems like that before. So now in number 2, what I'm going to do is I'm going to go from moles to atoms in a compound. So we're going to take this and we're going to go one step further. And the problem that I'm going to use is 7.9, 2 digits, moles of ammonium chloride is equal to how many atoms of hydrogen? So in the first problem, I'm going to do this 2 different ways. And in the first method, I'm going to start with 7.9 moles of ammonium chloride. And I'm going to say 1 mole of NH4Cl is equal to 6.02 times 10 to the 23rd molecules of NH4Cl. So what I'm doing is I'm going from here to here, and then from here, molecules to atoms, okay? So now I can cancel out my moles of ammonium chloride. And then for every 1 molecule of ammonium chloride, I have 4 atoms of chlorine. So that is what we learned at the very beginning of the year when I was saying, like, how many atoms of hydrogen are in 1 molecule of water? Oh, 2, right? So there are 4 atoms of hydrogen in 1 molecule of ammonium chloride. Okay? All right. So there's another way to do this. So let's look at this other way to do this before we solve it. So I can also do this, 7.9 moles of ammonium chloride. And then for every 1 mole of ammonium chloride, I have 4 moles of hydrogen. So this is using that subscript ratio that we talked about the other day. Right, so I made a mistake here. This is not 4 atoms of chlorine. It's 4 atoms of hydrogen because we're looking for hydrogen, sorry. So 1 molecule of ammonium chloride has 4 atoms of hydrogen, which is what we're looking for. Thank you. So here, I'm going to take the 7.9 moles of ammonium chloride. For every 1 mole of ammonium chloride, I have 4 moles of hydrogen. So this is still a little hard to wrap our heads around. How is it possible? And so what I want to do is I want to take a moment to sort of explain this concept. And the concept that I want to talk about is this. How is it possible that 1 mole of ammonium chloride can have 1 mole of nitrogen, 4 moles of hydrogen, and 1 mole of chlorine in it. So how is it possible that 6 moles of things could be in 1 mole of something else? So that doesn't really make any sense, and it's kind of hard to understand because moles are so big. It's kind of hard to understand how you could have 6 moles of these and they're all squished into 1 mole of this. So what I want to do is I want to take a look at this ratio concept with something that we're really familiar with. So I want to take a look at it with Oreos. All right. And so we know that an Oreo is 2 black wafers and 1 white creamy filling. Okay. And so we're going to call this a black wafer and a black wafer and a white creamy filling. All right. So that means that 1 Oreo is made up of 2 black wafers and 1 white creamy filling. Everybody all right? That's basically the formula. 1 Oreo is 2 black wafers and 1 white creamy filling. So if I have 1 Oreo, I need 2 black wafers and 1 white creamy filling. And if I have 2 Oreos, I need 2 times the 2 black wafers, right? 2 Oreos have 2 times the 2 black wafers, and then 2 times the 1 white creamy filling. Everybody see what I'm doing? If I have 3 Oreos, then I have 3 times the 2 black wafers and 3 times the 1 white creamy filling. See that? Everybody? Yes? Okay. If I have 20 Oreos, I'm going somewhere with this. I have 20 times the 2 black wafers, right? And then I have 20 times the 1 white creamy filling. Yes? Right. So if I have 1.0 times 10 to the 5 Oreos, I have 1.0 times 10 to the 5 times 2 black wafers, and 1.0 times 10 to the 5 times 1 white filling. Okay? Everybody okay? All I'm doing is multiplying up, right? Okay. And if I have 6.0 times 10 to the 23rd Oreos, then I'm going to have 6.002 times 10 to the 23rd times the 2 black wafers, right? And I'm going to have 6.02 times 10 to the 23rd times the 1 white filling. So far, everybody's okay with what I'm doing, right? Okay. We call this 1 mole, right? Okay. So if I have 1 mole of Oreos, then I have 2 moles, because 2 times 1 mole, 2 moles of black wafers. Right? 1 mole of 2 black wafers, 2 moles of black wafers. Everybody with me? And I have 1 mole of white filling. Right? Everybody with me? Okay, good. So look, 1, 2, 3 moles of things went into 1 mole of Oreos, right? 3 moles. 1, 2, 3 moles of things went into 1 mole of Oreos. Am I correct? Right. So if I have 1 molecule, then I have 1 atom of nitrogen, 4 atoms of hydrogen, and 1 atom of chlorine. But if I have 1 mole of this, then I have 1 mole of nitrogen and 4 moles of hydrogen and 1 mole of chlorine. So I have 6 moles of things that go into 1 mole of the ammonium chloride cookies. How's that? Everybody okay? That's where that molar ratio comes from. All right? And so, back here, I hope that helped. That help? Okay. All right. Back here, I can have 1 mole of ammonium chloride, and in that are 4 moles of hydrogen. How do I know that? Because it says right here, 4 moles, right? 4 moles of hydrogen. And now, because I want to know how many atoms there are, well, now it gets super easy, because for every 1 mole of hydrogen, I have 6.02 times 10 to the 23rd atoms of hydrogen. Now, if you look at my math, here I have 6.02 times 10 to the 23rd times 4, and here I have 4 times the same thing, right? So it's going to come out the same. Now, we're starting to get into some math where you guys are going to process things very differently. In fact, the next chapter, I actually tell you many different ways to do certain things, and you get to choose which way you want to do it. It's up to you. All right, and so this is the beginning of however you want to process this. That's up to you. But when we run this, we're always going to come out with the same answer, which in this case is 1.9 times 10 to the 25 atoms of hydrogen. Okay? Notice moles of hydrogen cancel moles of hydrogen. Molecules of ammonium chloride cancel molecules of ammonium chloride. Okay? Our next problem, and our last problem for today, we're going to do mass to numbers of ions. In a compound. So the problem we're going to work with is 12.3 grams of iron 2 nitrate. And what I want to know is equals how many ions? So the first thing that we would need to know here is in 1 molecule of iron nitrate, how many ions are there? So we're going to take 1 molecule of iron 2 nitrate and we're going to split it up, just like we used to do in those complete ionic equations. Remember those that you learned last chapter? So you learned how to do this because there was a test on it and you all learned how to do it. We went to the boards. So when you did this, you cross-crissed and you found out it was iron 2 plus 2 nitrates. So that's 3 ions. So for every 1 molecule of iron 2 nitrate, there were 3 ions, 1 iron 2 and 2 nitrates. So now the question is, in 12.3 grams of iron 2 nitrate, how many ions are there? So 12.3 grams of iron 2 nitrate. And I'm going to need to know the molar mass because I've got to get to moles. And the only way to do that, moles, mass to moles, is using the molar mass. So I'm going to add up 55.85 for my iron. I have 2 nitrogens for 28.02, and I have 6 oxygens for 90. 6. Right. So I get 7, 87, 14, 19, 6, 8, 179.87. So where am I going from here? Well, I need to get to ions, which basically is the same as atoms, right? It's basically the same place. So I need to get to moles or to molecules or something like that. So I'm going to go to moles. And now what I'm going to do is I know that for every 1 mole of iron 2 nitrate that I have 3 moles of ions. How do I know that? Because I can tell. I have 1 mole of iron and 2 moles of nitrates for every 1 mole of iron 2 nitrate. So for every 1 mole of iron 2 nitrate, and the reason I'm being so clear here is because then I can cancel this out. So I want to be really clear. I have 3 moles of ions. But I want to know how many there are. So for every 1 mole of ions, I have 6.02 times 10 to the 23rd ions. So moles of ions to moles of ions, and then I go actually to individual ions. And then when I multiply this out, I get 1.23 times 10 to the 23rd ions. So that's how many ions there are in 12.3 grams of iron 2 nitrate. Questions on any process that I did in here? Yeah, Charles. So I know that when I put the iron 2 nitrate together, if I do a crisscross on this, if I do a crisscross here, that 2 comes down there to the nitrate, and the 1 comes down here. And so I get Fe1, and then NO3, and the 2 is there. So I have to put this in parentheses. So that means that there are 2 nitrates at -1 and 1 iron at +2. So the nitrates at -1, -1 times 2 is -2, right? And this is +2, so they cancel out. So I know that there's 2 of them, and there's 1 of these, so that's a total of 3 ions. Okay, so that means for every 1 molecule of iron 2 nitrate, there are 3 ions. That is what I know. So I need to get to molecules, and then I can tell you how many ions there are. Because for every 1 molecule, there's 3 ions. So to get to molecules, I go from grams to moles, and then I'm going to go from moles to molecules, right? Moles to molecules. Once I get there, I can just go from molecules to atoms or ions. So I went from grams to moles, and then I used that molar ratio, right? And I know that for every 1 mole of iron 2 nitrate, there are 3 moles of ions because of that molar ratio we just talked about. And for every 1 mole of ions, there's 6.02 times 10 to the 23rd of them. All right, so here are examples of 3 types of equations that you're going to need for your homework. Now remember, you need to look at what you want to start it, and then look at what end unit you need to end it. All right? And then figure out how to get there. Do your best. There's only one that might be a problem that I see, so do your best on that one, and then you should be able to finish it, okay? Finish them all, okay? All right, get started on your homework. Your books are right in front of you.